All right, guys, we're going to jump right into this graphing quadratics unit, and it's really to create a visual of our polynomials and our specific polynomials. In semester one, great, we had an emphasis on our linear, right, functions, dealing with our slope, dealing with our y-intercept, and finding that consistent, right, change on this graph. In semester two, we've had a crazy emphasis on our quadratics. And we haven't seen a visual of this quadratic function yet. So I think it's going to be important to define just some basic key features. We've dealt with some key features in the past that we'll see a little bit later on today, but we have some key features specific to quadratics that we need to address. So our standard form of our quadratic function, right, we write that as f of x and then equals that standard form with our decreasing degree, right, thinking about that x squared, then x, and then our x to the 0 or that constant value. Again, we're looking at that quadratic function from largest degree to smallest degree, right, that x squared, then x, then that x to the 0 power, aka that constant. Again, the highest degree of this function, because it is a quadratic, will be 2. Right? If we see an x to the third, automatically, right, not a quadratic function, we have that cubic function. A lot of these things don't apply. These coefficients, right, our a, our b, our c, sure, will be replaced with numbers later. And based off of the sign, whether they're positive, negative, how big that number is, it will change that graph. It'll shift it left, right, up, down. It will stretch it. It will shrink it. Again, we're going to go into a lot more depth a little bit later on when we're going to actually graph these functions. But for now, we're just going to be looking at our functions and pulling out some key characteristics. One of those characteristics that's different is this idea of a vertex. And that vertex is going to be the highest or lowest point on the graph. And with this, we are going to write it as an ordered pair, right? So x comma y. And within that vertex, we can pull out some key info from that. Our min-max value, that's just the y-coordinate of the vertex, and we just write this as a number. So when it says the minimum or maximum value, you'll identify if it's min-max, and then you'll say what that number is, right? What that y value is. Your axis of symmetry is actually going to be a vertical line, and it's through the vertex. Right? And when I see this word axis, I think, oh, x, y axis, those things are lines, so I have to write it as a line as well, right? So we're going to write that axis of symmetry as x equals a number. And specifically, we can take that from our vertex, the x value from that vertex. Okay, so let's take a look at this parabola. Couple examples in this parabola. Pick out our vertex, find our y-intercept, find our x-intercepts, and then talk about this min-max value. I'm going to jump around a little bit, but I think it's going to be more beneficial so we can tie in a couple of these main ideas together. So looking first, right, for our vertex, it is the top or the bottom of that U. So looking at the shape, right, I see the top of that U is here. This is the vertex. And a lot of the things that we're chatting about today are all surrounded around this vertex. So let's write out that ordered pair. So my x value is 2, that y value is 4. So my vertex, I'm writing it as 2, 4. Within that vertex, I have an axis of symmetry, a dotted line that reflects something from the left-hand side of that quadratic to the right-hand side. Right, so I can create that dotted line straight up and down through that vertex. And this is called my axis of symmetry. Again, when I'm writing out that axis of symmetry, it's going to be x equals. And what does x equals within that vertex? Well, 2. So I'll write it as x is equal to 2. Okay, again, going to stick with the vertex idea, right? Axis of symmetry. The other thing that I want to talk about is whether this vertex is a minimum or a maximum, right? So looking at this, this is the highest point, right, of that U. That's going to be a max value for me. With that max value, I'm just simply going to write out what that y value is. So it's at a maximum of 4. And we always talk about that y value. Looking at our quadratic, right, we have it facing down. So I like to think about this as like a smiley face or a frowny face, right? It is facing downwards, right? So it opens down. Makes us sad. What happens with this is it makes that a value negative. So these are really all of the things that we can take away from that idea of a vertex, or some very simple, just some straightforward ideas from our parabola. Other things that we can take away, probably we can tie this into our semester 1 info, is this idea of our y-intercept. Right, so we have our y-axis as that vertical line running straight up and down throughout that graph. So looking to see where the blue parabola crosses with that black y-axis, right, is that purple point now. So I know my y-intercept, and we only have one of these, is going to be 0, 3. The symmetric point, it's a little bit of a funky idea, but basically you're taking it from, or you're finding that symmetric point on the opposite side of that axis of symmetry, right? That symmetric point is the same distance for your axis from your axis of symmetry. So if I go from my y-intercept to my axis of symmetry, that's 2 points. Another 2, and that's that reflected point. So we can write out that point of 4, 3, and then getting into the y-intercept or the x-intercepts, just where it crosses that x-axis. So I have that black x-axis with that blue parabola. Man, that pen just went crazy. With that blue parabola, right, hitting those light blue points. So I can write out those x-intercepts as ordered pairs of -2, 0, and then 6, 0. And then we get to our domain. Our domain is our smallest x value to our largest x value. Our range, smallest y value to our largest y value. So with this, our range will change, dealing with if it is a frowny face, right, we have all of those negative y values, right, negative to negative infinity to that absolute maximum value of 4. So dealing with that vertex does help us determine our range within these parabolas. All right, so if you're feeling pretty confident with some of these ideas, I definitely suggest pausing the video and trying this second example on your own. If you're needing a little bit more structure with this, definitely keep the video playing. As again, I continue to dive into all of these ideas. So we're going to talk about our vertex to start with this. Vertex, again, is the where the highest or lowest point is on that U, and we'll write that vertex as an ordered pair. So that vertex is written as -1, -9, and our axis of symmetry runs through that vertex. And we write that as a line. So we're going to write that as x is equal to -1. Again, that axis of symmetry reflects those points from that left-hand side to the right-hand side. Continuing on with this idea of our maximum, or right, that vertex value, technically we have our minimum because this is the smallest point. So we have a minimum value here. And that minimum value is at -9, that y value. The quadrilateral, that parabola opens up, right? That idea of our smiley face, which makes our a value a positive value. All right, going back to our y-intercepts, right? Where does this graph hit that y-axis, right? That blue graph hits our y-axis at this point, right? Intercepts it. So we have our y-intercept at 0, right? Left, right, nothing, but then down 8, so -8. When we're finding that symmetric point of our y-intercept, we can start on that y-intercept and count to our axis of symmetry. So with this, I have 1 unit. I count 1 more unit onto the other side, and that symmetric point will be -2, -8. Our x-intercepts are where this parabola crosses the x-axis, right there, and then right there. So I'll write out those 2 ordered pairs. So I have 2, 0, and then -4, 0. Our domain will remain consistent with our quadratics for -infinity to positive infinity. And then our range, we technically have our smallest value, right, our minimum value to be -9, and it includes that value all the way to positive infinity.